It's me, Mrs. Ogden, and I'm coming to you live tonight from my office here in my home. Now, I've removed the pictures of my wonderful children from our walls so I can teach you about the law of sines. We've already learned a lot about trigonometry. We've learned how to use right triangle trigonometry to solve lots of problems. But we have another problem. What happens when we don't have a right triangle? For that, we have the law of sines. The law of sines tells us that for any triangle, and here we're going to use the triangle ABC, the following proportion is true. This is an extended proportion here, so it has three fractions. A over sine A is equal to B over the sine of B equal to C over sine of C. Now you can see I've drawn three triangles here, an obtuse triangle, an acute triangle, and a right triangle to show that this works with any triangle. You want to remind yourself that the capital letters represent the angles, so we can take the sine of each of these angles, and the lowercase letters, lowercase a, b, and c, represent the sides of the triangles. When you're setting up the proportions, it's helpful to remind yourself that A goes with A, B goes with B, and C goes with C. And notice all of my sides are in the numerator of the fraction, all of my angles are in the denominator of the fraction. Now, like I said, we use the law of sines when the triangle is an oblique triangle, that is, not a right triangle. We can use it with the right triangle, but why would we do that? We could just use regular trigonometry and not have to put ourselves through remembering another formula. Now, this requires some information. If we're going to use a proportion, remember you want to have 3 out of the 4 pieces of that proportion filled in. So I need to generally have 2 angles and 1 side. Now, we can do this with 2 angles and the side between them, or 2 angles and what's called a non-included side, so the side that's not between the 2 angles. But it doesn't really matter that much. A less desirable situation that sometimes works out okay is when we have 2 sides and 1 angle. That's called the indeterminate case, and I won't talk about it in this video. I'll talk about it in another video. So I want to bring up my problem here, so I'm going to take down my first slide and bring up my second one.